Okay, if you have a Ti-83 calculator, one that looks like this, or you have a Ti-84 Plus calculator, one that looks like this, please continue watching this video for instructions about how to make a regression function for this problem. The first thing you need to do is enter the data into your calculator. So press Stat, Edit. If you already have stuff in there, you can scroll to the top and press Clear and Enter, or individually press Delete, this button here. Okay, this first column is like our X column, so I'm going to enter in the years. Of course, we changed the years to be years since 1980, so I'm entering 0, 5, 10, and so on, up to year 25. Okay, next I'm going to enter the Y values. After every time, I'm just pressing Enter to move to the next value. Okay, so now that I have the data chart entered, I want to take a look to see what this looks like. If I press Graph, it may be that you have other stuff you need to clear out, and it may be that you still don't see the data values. Check two things. First, when you press Y equals, make sure plot 1 is highlighted. That tells your calculator, go ahead and plot the data points. Otherwise, it only plots the functions that you plot. As a reminder, make sure you are writing these directions down, including which buttons to press. So now that plot 1 is highlighted, I like to go to Zoom and scroll down to Stat, because that just gives me a nice window. Oh, there are my data values. And as I noticed, yeah, the Y values are going down and then going up. So this graph allows me to choose the type of regression that I want. Now it's time to calculate the actual regression function. Press Stat and go to Calculate. Now there are lots of options. I can make a linear regression, quadratic, cubic, quartic, right? Tons of options here. We'll focus mostly on linear regression, quadratic regression, and maybe a little bit of exponential regression to get us started. Because my graph showed, if I press Graph again, or again if I press Zoom and Zoom Stat for statistics, I can see that the data values go down and then they go back up. So a quadratic function will be a better fit than a line or a linear regression. So I'll press Stat, Calculate, choose a quadratic regression. This is using list 1 and list 2 for my X and Y values, so I could just scroll down to calculate. Okay, here's my function. So this is giving me, in the first line, a template for where what my answer is going to look like. That's like saying you'll have, Y equals A. In this case, I can see A is 0.004. And then ax squared, this is just the standard form of a quadratic function, 0.004x squared plus bx, and they're giving me b right here. Oh, so that would be plus a negative or just minus 0.093x. Up at the top, my template plus c, so just plus this final number, which is 2.607. So, example 1, find a function that models the data below. Here's this function that best fits. Justify your choice of function. We chose a regression function because there was not a perfect pattern between the change in X values and the change in Y values. We chose a quadratic regression rather than a linear regression because the Y values decreased and then increased, whereas a linear function is just going to go strictly up or strictly down. Okay, let's take a look at our second example. Again, we're going to change these X values. I'll copy. Oops. We'll change the X values to be time since 1013. So we'll rename this 0. This would be 2 minutes later. This would be 4 minutes later. 6, 8, and 10 minutes later. And we'll call time the number of minutes since 1013. Okay, again, first thing I need to do is enter the data, press Stat, and Edit. To clear them out, I can either press delete, 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 delete for each individual value, or I can go up to the top, press clear, and then enter. That'll clear the entire list. So I need to enter my minutes into the first column. I need to enter my Y values, the temperature, into the second column. Double check to make sure my values are right. Okay, I'm going to have to choose between a linear, quadratic, or exponential function. Again, when I'm looking at these Y values, I see, let's see, this is going down by about 15. This temperature is going down by about 20. This is going down again, but they're not going down all by the same values, right? This is going down by about 17. So if the function is just increasing, maybe I'm not sure exactly which of these three functions will best fit the data. There are two ways to decide which type of regression function you should look at. One way is to look at the graph, make sure plot one is highlighted, press zoom and stat. I have different values here, so it'll fit a nice window. You can press enter. Oh, to me, this looks like maybe it's a linear function, but I don't know, maybe there's a curve, and maybe you don't even really remember what exponential functions are. So there's a way to be precise in determining which type of function best models the data. You'll have to do this once. Go to catalog. Catalog for me is blue and above 0, so I have pressed second catalog. I'm going to scroll way down to diagnostic. This you should only have to do one time. So you can jot this down in your notebook, but only do once. When you get to diagnostic on, press enter, and then press enter again. It should say done. Okay, let's run a couple types of regression and we'll see what we get. Let's first calculate a linear regression. Scrolling down to calculate. I want to write down this value r squared because the closer r squared is to 1, the better the data fits your graph. So for a linear regression, I had r squared was equal to, let me jot this number down, 0.986 if I'm rounding. Okay, let's try to calculate a quadratic regression. Oops. This time I get an r squared that's higher, 0.989. Really, you could round it to 0.990 for a quadratic regression function. So a quadratic function actually better fits the data than an exponential function. Let's try one more. Scroll down to that exponential regression function. 0.994. Oh, that's the best one yet. So let's use an exponential regression function because the r squared value is highest. That tells us that the data is best fit by an exponential function. Maybe you don't remember what it looks like, but here's your cheat sheet up at the top. The function will have the form y equals a times b to the x, where here are what a and b are. So let's write it out together. Y equals A is, in this case, 180.34. You can round to a couple decimal places if you wish. Times B, so I'm going to multiply by 0.95 to the x power. I'm getting that from this first line right here. Okay, let's make sure we answered the question. A cup of tea is left on the countertop. Write a function that models the relationship between time and temperature above. And again, we chose an exponential regression function since it had a higher r squared value than a linear or quadratic function. We had to use a regression function. Like, why didn't we just write an exponential function? Because the data had no perfect pattern. They weren't decreasing by the same value each time.